All right, so because I am not in the building today, you are going to pick up where we left off in our lesson on Friday. And we're going to get through examples 3 and 4 here on the front of the notes, as well as a couple of the practice problems. So we're going to go through these together, and then with the practice problems, the video is going to pause, you're going to solve them, and then you'll see how you did. Okay, so we're talking about example 3 here. And this is a situation that has two inequalities baked into it. So we've got one inequality here that says 2x minus 1 is less than negative 7. That's the first inequality. Then we've got this other inequality, negative 3x plus 1 is less than negative 11, and they're attached with this symbol here. What this symbol here means is basically the word or. So we're going to make a note to ourselves that this symbol means or, and if we ever see this symbol, which we will, that will mean and there is a difference that you'll notice in the way that these solutions play themselves out depending on which type of scenario we're dealing with. In either case, we're basically going to deal with each individual inequality, and then we'll view the solution at the end using the and or the or. So we're going to go ahead and solve this, and then we'll go ahead and solve this, and then we'll talk about what the solution means at the end. Okay, so the inequality on the left, relatively straightforward. We can add 1 to both sides, and that's just going to be negative 6. All right, and then we have 2x is less than negative 6, so we can divide both sides by 2. We don't need to flip the sign because the 2 is positive, and we end up with x is less than negative 3. Now remember, this symbol means or, and over here we've got, if I subtract 1 from both sides, I've got negative 3x is less than negative 12. Then I'm going to divide both sides by negative 3. That will cause this to flip, and then I have x is greater than 4. So this is my solution here. I'm going to box my answer. That's my answer, is that either x is less than negative 3 or x is greater than 4. And if I put that on a number line, I'm going to have my negative 3 over here and my 4 over here, and so my solution set is these numbers or it's these numbers. We've got those two different situations. Okay. So in this situation, when we talk about values that satisfy this inequality, this disjunction of inequalities, it's these or it's these. Now the scenario beneath it is one of those and situations, but you don't see that symbol. What you actually see here is an inequality within another inequality, and they're like smushed together like this. So what this reads is 4 is less than or equal to 2x minus 6 is less than 8. Now another way to view this would be to say 4 is less than or equal to 2x minus 6, and at the same time 2x minus 6 is less than 8. So that's what we're seeing here. This is an abbreviated way to write a conjunction like this. So we're really going to treat it like this situation here. We're going to solve this one, and then we're going to solve this one, and then we're going to see what we end up with. So if we were to solve the inequality on the left, I would add 6 to both sides. Okay, and then I would divide by 2. And on the right, I would add 6 to both sides, and then I would divide by 2. All right. Now what you're going to notice is that in both cases, I added 6 to both sides first, and then I divided by 2 second. I did the same exact thing in both cases. So if you did want to save yourself some time, you could do it all right here. As long as you do the same thing to every part of the inequality as you go. And then we could divide by 2. Now this says the same thing that this says. 5 is less than or equal to x and x is less than 7 is the same thing as x is in between 5 and 7, also including 5. So when I graph this, I've got my number line. I'm going to put 5 and 7 on the number line. Since x can be greater than or equal to 5, I am going to close in the 5, but 7 needs to stay open, and it's all the values in between 5 and 7, including 5. So that's my solution set to this conjunction of values. Another thing that I want to point out here is there is alternate notation for giving these answers. So I can give my answer like this, where it says 5 is less than or equal to x is less than 7. But I could also use what we call interval notation. And I could write that same expression like this, indicating that my values have to be between 5 and 7, not including 7, but including 5. All right, so the way that this notation works is that if I'm using a bracket, that's like saying or equal to, and this is just a less than or a greater than, depending on the situation. So this is interval notation. If I wanted to write my answer to this problem that way, this is how I would write it. I could use interval notation on the problem above too. I would just need two different intervals. So to express this interval, I would need to say that it's all the values from negative infinity to negative 3, not including either of those values. And then I would use my or. It's all the values from 4, not including 4, to infinity. So if I did want to use interval notation, I could do that here. I could do that on the one above too. I could say it's all the values from negative infinity to negative 27, not including either of those values. So interval notation sometimes is quicker and a little bit more efficient. Okay, so practice problems are going to deal with these conjunctions and disjunctions. All right, so we're going to do all 4 of these, and then the video will pause. You'll give your solution, and then you'll be able to see my solution to see how you did. Okay, so we'll go ahead and do this first one. I'll give you a minute to go ahead and solve that inequality, and then go ahead and graph it on a number line as well. So in my solution, I am going to treat these two things separately, and I'm going to add 4 to both sides in the first case. So x is less than or equal to 6, and x is greater than negative 3. So this is an acceptable way to write your final answer. Another way to write your answer here would be to say that x needs to be between negative 3 and 6, including 6. This is the same thing. We'll see that in a second when we graph it on the number line. Or the third way to do this would be to say that it's all the values between negative 3 and 6, including 6, but not including 3. So 3 different ways to write our final answer here. And what this would look like on a number line is we'd have our negative 3 down here and our 6 up here, and I can include 6, but I can't include negative 3, and these are the values that satisfy that inequality. Let's go ahead and do the second one. So again, I'll solve these separately. I'll have y is greater than or equal to 6, or y is less than 0, once I subtract 1 from both sides. Okay, so this is an acceptable way to write our answer. And when I graph it, we'll put 0, we'll put 6. Y has to be greater than or equal to 6. And or it has to be less than 0. So these are the two situations. And if I wanted to use interval notation, I could say it's all the values from negative infinity to 0, not including 0, or the values from 6 to infinity, including 6. So that's interval notation. Let's go ahead and solve this one here. And I'm going to make a change. I'm going to turn this into an or, sorry about that, or an and. We'll make this a conjunction. Okay, so I'm going to solve the inequality on the left first. I'm going to add y to both sides. And then I'll go ahead and subtract 2. And then I'll divide by 3. So y is greater than 1. And I'll add 2 to both sides and divide by 2. Y is less than 4. Okay, so when I graph this, we've got our 1, we've got our 4. Both of these are open, and y is greater than 1 while simultaneously being less than 4. So it's all of these values. So a nice condensed way to write this would be like this. Or if you wanted to put it in interval notation, you could say that it's all the values between 1 and 4, not including either. And finally, the fourth problem. So here you can break them apart, and you can have this be 2 different statements connected by an and. I'm going to subtract 4 from both sides. It's the same thing. So this says -7 is less than x, and x is less than or equal to 1. And we can go ahead and graph this. We're not going to include the -7. We are going to include the 1. And that's our graph of our solution. This is an acceptable way to write our solution. We could also say that it's all the values from -7 to 1, including 1, but not including -7.